Hello and welcome to another Algebra 1 video by eMath Instruction. My name is Kirk Weiler and today we're going to be doing Unit 1, Lesson 3 on the distributive property. In the last lesson, we looked at two important properties of both multiplication and addition, the associative and the commutative properties. Today, we're going to look at the third major property of real numbers with addition, multiplication, and division and subtraction are going to come in a little bit to this one. Anyway, let's get right into what the distributive property is. All right. So an elementary warm-up problem, because anytime you have a property, you want to kind of understand why it works, not just memorize it. So let's take a look real quick at exercise number 1. Consider the product 4 times 15. Letter A, evaluate using the standard algorithm. All right, so let's do this, right? Let's do it together. It's fun. This is like, take me back to 4th grade, if even that, maybe even 3rd grade. So here we go, right? So if I was gonna do this the long way, right? I'd say, I've got 15 times 4, right? And I'd do 4 times 5 and I'd get 20, right? I'd carry the 2 and I'd do 4 times 1, which is 4, plus 2, which is 6. And so I'd get 60, right? And there's nothing wrong with that. Now let's take a look at letter B. Right? Letter B says represent the equivalent product 4 times 10 plus 5 as repeated addition of 10 and 5. Find the product. Right, so keep in mind, right, I think some very obvious things. 1, 15, right, is the same as 10 plus 5. Okay, 15 and 10 plus 5 are the same thing because 10 plus 5 is 15, right? They're equivalent, as we say in math. And of course, the other thing is that multiplication just means repeated addition. So 4 times 15 literally means 15 plus 15 plus 15 plus 15. So I can think of 4 times 10 plus 5 as being, right, 10 plus 5 plus 10 plus 5 plus, hopefully I'm going to have enough room, 10 plus 5. Maybe that last one's going to be a little small, but we got it, right? That is 4 times 15, right? But remember the associative and commutative properties of addition. Those allow me to rewrite this long addition problem in a variety of different ways. So one of the ways I'm going to rewrite it right now is I'm going to rewrite it as 10 plus 10 plus 10 plus 10 plus 5 plus 5 plus 5 plus 5, right? Just rearranging it. And ultimately, what does that mean? Well, I've got 4 times 10 plus 4 times 5. Now, before we finish that, I just want to point out, right? What I'm saying is that 4 times 10 plus 5 can be thought of as 4 times 10 plus 4 times 5. And that is known as the distributive property of multiplication. Its technical term is the distributive property of multiplication over addition, but whatever. And then, of course, 4 times 10 is 40. 4 times 5 is 20. And add those together and we get that 60 that we had before. That's not really the interesting thing. The interesting thing is that when we multiply a sum, this also works with differences, with subtraction, we can actually multiply each part of the sum and then add. And that is so very important. And it's not necessarily an obvious thing the way that I think the commutative and associative properties of addition are. Let's take a look a little bit more at the distributive property. Right, here it is in its glory. The distributive property of multiplication over addition or subtraction. If A, B, and C are all numbers, or variables that represent numbers, doesn't make any difference, then A times B plus C, or A times B minus C, that's what that little plus with a minus symbol underneath it means. I can either be doing B plus C, or I can be doing B minus C, but all this the distributive property says is I can first do the multiplication, A times B, A times C, and then I can do the addition or the subtraction. Teachers will often show this with kind of like little drawing arrows. They'll kind of show this distribution, right? We're distributing the multiplication. Each part of the addition or the subtraction gets the multiplication, all right? Let's take a look at how we can use the distributive property in purely numerical settings. Exercise number 2. Evaluate each product by using the distributive property to make it easier. On B, express 18 as a subtraction. Do not use a calculator. Okay, so here's what I mean. Now, I know that you can all do 7 times 23 using the standard algorithm. It's not that. I want us to be able to think about it, though, like this. This is the same as 7 times 20 plus 3. All right, in which case I can distribute this multiplication to say, well, I've got 7 times 20 plus 7 times 3. 7 times 20 is 140. 7 times 3 is 21, and then I can add those together to get 161. Now, see if you can do the same thing as 9 with 9 times 18, but instead of writing 18 as 10 plus 8, or, 9 plus 9, or whatever you want, try the distributive property with subtraction by writing 18 as 20 minus 2, and then do the distribution. Pause the video now and see what you get. All right, let's go through it. Now again, I'm showing you this mainly to illustrate the distributive property. If you were actually doing this product, you should do it any way you want, right? But I'm going to get 9 times 20 minus 9 times 2. 9 times 20 is 180. 9 times 2 is 18. And 180 minus 18 is 162. Boy, I like those. 161 and 162. I don't think I even meant for them to come out that nicely or that closely. Maybe they're not nice. All right. Point is, right, whenever I have a product of a sum or a product of a difference, right, I can distribute the multiplying factor through the difference or through the sum, evaluate the two products, and then add together. You might, think, why would I want to do that, right? Well, because sometimes it can make multiplication easier, but mostly, again, it's so that we can manipulate algebraic expressions to make them simpler or to put them in a form that tells us something different than the form they're currently in, whatever that means. All right, let's keep going. All right, let's take a look at exercise number 3. The distributive property can be used twice in order to multiply two-digit numbers. Find the product of 12 times 28 by evaluating 10 plus 2 times 20 plus 8. Show each step in your calculation. Do not use a calculator unless it is to check. All right, this is what's called double distribution, and this can really kind of mess with kids. But let's take a look at it, right? So in other words, what I'm trying to do is 12 times 28. But what I'm going to do is I'm going to replace the 12 with something equivalent, 10 plus 2. I'm going to replace the 28 with something equivalent, 20 plus 8. You could also replace it with like 30 minus 2 or a variety of things. Now, right, keep in mind that ultimately I have something times 20 plus 8. Whatever that thing is, no matter how complicated it is, that thing is multiplying 20 plus 8. So now I can distribute that thing so that it's multiplying both the 20 and the 8. Literally, this whole thing I want to look at as a single thing for right now, and I can rewrite that as 10 plus 2 times 20 plus 10 plus 2 times 8. Right? And really, what am I really doing? I'm really doing 12 times 20 plus 12 times 8. That's all. But now I can actually do the distributive property this direction, right? It doesn't matter. Multiplication's commutative, right? I can flip-flop those, right? I can think of this as 20 times 10 plus 2 and 8 times 10 plus 2 as well. So in other words, I can distribute this, and I end up getting, give myself a little more room, 10 times 20 plus 2 times 20 plus 10 times 8 plus 2 times 8. And now we just have to figure out all these products. 10 times 20 is 200. 2 times 20 is 40. 8 times 10 is 80. 2 times 8 is 16. And, right, now I have 240 plus 80 plus 16. I have 320 plus 16. And I have 336. The weird thing is, if you were to actually write out the standard algorithm, 12 times 28, right, and you were to actually evaluate this using the standard way that you evaluate multiplication, you really are doing all of this. You probably just didn't realize it, right? If you think about it, right, you did 8 times 2, 8 times 1, right, or really 8 times 10, then 2 times 20 times 2, and then 20 times 10, right? You're getting all of those products in here. You're just doing it in a way that would have been understandable when you were in 3rd grade. Now, we actually know it's the distributive property. All right, let's keep working with the distributive property. We got to get some variables involved, right? Using the distributive property when variables are involved. Exercise number 4. Express the following products as binomial expressions. Show each step in your calculation. All right, we'll get into a lot more lingo, like what are binomials, what are trinomials, what are monomials in future lessons, right? But right now, let's just take a look at letter A, where we have 5 times 2x plus 3, right? We have a product of 5 times a product of 2 things that are being added together, those 2 things being 2x and 3. So if I wanted to simplify this, right, what I could do is I could distribute the 5, right? And that's going to be 5 times 2x plus 5 times 3. Now, before I finish this off, of course, 5 times 3, that's simple enough, that's 15. But what do I do with 5 times 2x? Well, keep in mind this is 5 times 2 times x. And the associative property of multiplication, the associative property, tells me when I'm multiplying 3 things together, 5 times 2 times x, I can multiply them in any order I want. So in other words, I could think about this as 5 times 2 times x, and I'll just put the plus 15 right now, and then 5 times 2 is 10, and I get 10x plus 15. That's it, right? But keep in mind, what I'm using right here is a property that we talked about in the last lesson, the associative property of multiplication. I'm allowing myself to multiply the 5 and the 2 together to get 10, and then have the x just sitting there as multiplication, right, in that expression. Okay. What I'd like you to do is try letter B. Be a little bit careful here because we're multiplying by a negative number, but see what you can get there. Pause the video now. All right, well, there's a bunch of different ways to kind of think about this one. It may be helpful, right, to originally write this as negative 4 times 5x plus negative 8. You don't have to do that, but some students find it a little bit easier, right? When I distribute it through, I'll get negative 4 times 5. I'm going to do that associative property right away, times x, plus negative 4 times negative 8. All right, negative 4 times 5 is negative 20, x. Then negative 4 times negative 8 is a positive 32. Remember, a negative times a negative is a positive. So we end up with negative 20x plus 32, right? Basically what we're seeing, let me kind of erase this so you can see it a little bit better, is that when we multiply a subtraction, right, 5x minus 8, by a negative number, that subtraction turns into an addition, right? Negative 8 times negative 4, positive 32. All right, let's get a few additional variables involved though, right? So far we've just been multiplying through by, right, by a constant. Let's now multiply by some variables. Let's take a look at letter C together. Here we have x times the quantity x plus 4. And again, we're just distributing that multiplication by x through. So we'll get x times x plus x times 4. Now, x times x by definition is what we call x to the second power. And this is more or less done, except we never write it as x4. We always write it as 4 times x, all right? So never ever leave something like this. This is just, you know, for a math person, this just doesn't make any sense at all. Even though it probably should, right? We always want to have that numerical coefficient, is what it's called, first and the variable second. So let me erase that. All right. What I'd like you to try now is letter D on your own. All right, let's do it. So now we're multiplying everything in this parentheses by 5 times x, right? And if it helps, you can put a parentheses around the 5x. Okay, we're going to distribute that through. So we're going to have 5x times 2 minus 5x times 7. And again, I can rearrange these, right? I can rearrange the multiplication using that associative property and commutative properties. All right, and actually that's a 7x, I apologize for that. So that's 5 times 7 times x, right? Get some equal signs here. 5 times 2 is 10. So I get 10x minus 35 times x to the second power. All right. And again, what we really want is we want this to become automatic, right? So that we just, I've got 5x times 2, that's 10x. I've got 5x times 7x, that's 5 times 7 is 35. X times x is x squared, and then we have the subtraction because I don't have any kind of negatives multiplying through. So I get this new expression. All right. Let's do one more problem. All right. Now, one of the cool things is that the distributive property also works with division. Students tend to think about it less, and often it comes up when we have fractions. We almost never see the division symbol, right? We never, ever see this at the Algebra 1 level. That symbol's not going to even happen. By the way, do you notice there is something very similar about this symbol in the fraction bar? It's almost like that symbol is the fraction bar with the dot on the top and the dot on the bottom representing the numerator and denominator. That really is kind of the case. But what the distributive property says with addition is if I have b plus c or b minus c divided by something, then I can divide both portions of that sum or difference by that quantity. All right? That's it. The distributive property, but with division. And the distributive property gets used with the division quite often in order to simplify expressions involving fractions. I think that's a good way to put it. So let's take a look at exercise number 5. Express each of the following quotients as binomials in simplest form. A quotient is just a division problem or a fraction. A binomial is something with 2 terms. Show your calculations. Some of your final answers will contain fractional coefficients. All right, so let's take a look. So this is what we're getting at, right? If I have 8x plus 4 all divided by 2, I can rewrite that as 8x divided by 2 plus 4 divided by 2. I can furthermore think about this as 8 divided by 2 times x plus 4 divided by 2. Of course, 8 divided by 2 is 4, so that's 4x plus 2, right? And all I've really done is I've just divided 8 by 2, and I've divided 4 by 2. That's it. Simple enough. Why don't you go ahead and try to do letter B on your own, and then we'll take a look at letter C and D, which involve some additional fraction work. All right, let's take a look at letter B. So very, very similar, letter B. All right, ooh, let's get rid of that. Right, we have 25x divided by 5 minus 50 divided by 5. Again, I think it's very helpful to kind of separate it like this, especially for when we get into the next problems, right? Because then I can say 25 divided by 5 is 5, 50 divided by 5 is 10, so I get 5x minus 10. All right, now, letter C and letter D are more challenging because division doesn't always produce whole numbers, right? Division often actually produces fractions as final answers. So let's take a look at that in letter C. All right, here we have 2x minus 16 divided by 4. So I can break that into 2x divided by 4 minus 16 divided by 4. Now, so far, it looks pretty similar to the problems I've been doing. I have 2/4 x minus 16/4 The key here now is that I have to reduce this fraction because that's not a whole number, right? 2/4 is the same as 1/2. Now on the other hand here, 16/4 is the same as 4, right? 16/4 is just 16 divided by 4, that's 4. So we get 1/2 x minus 4. Letter D, a little more challenging. Pause the video now and see if you can work through letter D. All right, let's do it. Letter D, right? We get negative 9x divided by 12. We're not going to worry about that negative right now. 18 divided by 12. Again, kind of just breaking it down. Negative 9/12 x plus 18/12. And now this is really just take me back to simplifying fractions, right? If I was asked to simplify the fraction negative 9/12, well, first it's negative. But if I divided both numerator and denominator by 3, I would get negative 3/4, right? Same thing with 18/12. I can divide both the numerator and denominator by 6. That would be 3/2. So negative 3/4 times x plus 3/2, or plus 1.5, right? You want to get work, basic work with fractions when you have a chance like this. Resist using your calculator unless you are simply checking your final answers. All right, let's wrap this up. Okay, today we saw the third major property of real numbers that goes along with addition and multiplication and subtraction and division, the distributive property. Oh, we're going to use the distributive property a lot. Now, I'm sure that you've also used it quite a bit already when solving equations in previous math classes or simplifying expressions or what have you. But we'll take it to a whole new level in Algebra 1. For now, I just want to thank you for joining me for another Algebra 1 lesson by eMath Instruction. My name is Kirk Weiler, and until next time, keep thinking and keep solving problems.